Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at, well, we're actually doing a sort of introduction to the next topic, which is basically graphs, looking at graphs, what do graphs look like, cubic graphs, quartic graphs, and asymptotic graphs, which we will talk about all in the future, and also transformations of graphs, okay? And again, this is something that we will talk about. This is the new topic, so sort of a subtopic of that is different. These are called polynomials, okay? And we're looking at the graphs of different ones of those. Now guys, we just need some notation. We need some extra words in our vocabulary, okay? What on earth is a polynomial? Big word, what is it? Sounds very mathsy. A polynomial, I mentioned it in a video a while ago, about when we have making substitutions to solve quadratic polynomial equations. Basically, a polynomial is something that follows this pattern, okay? So we have constants, linears, quadratics, cubics, quartics, quintics. They go up and up and up forever, okay? And as you can see, there's a term plus a constant times x, term plus a constant times x plus a constant times x squared, term plus constant times x plus constant times x squared plus constant times x cubed. It goes on forever, right? It's basically powers of a variable, x, t, u, whatever. These are all polynomials in a way. Now, don't be pedantic, guys. Like, y equals c is not really a polynomial, okay? I wouldn't call it a polynomial. Y equals c is just a horizontal straight line. Linears, like, would you call that a polynomial? I don't know. I would say quadratic and above is typically, like, that is decided. That's a proper polynomial. A quadratic, a cubic, a quartic, a quintic. Now guys, quadratics, the highest order term, we've talked about them endlessly, the highest order term of a quadratic is an x squared. It does not go higher than that. You do not get an x cubed in a quadratic, ever. If you do have an x cubed, it is a cubic. If you have an x to the 4, it is a quartic. If you have an x to the 5, it is a quintic, etc., 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 okay? Now, something to note is that if any of the other terms, other than the front most, the sort of leading term, if any of the other terms are 0, that is fine. So an example of, let's say, a quartic could be y equals, let's say, x to the 4 plus 2x squared plus 3. That's a quartic. You might say, hold on, where's the x cubed term? Where's the x term? It's just an x to the 4x squared. It's still a quartic, because it's got an x to the 4 in it. As long as it's got an x to the 4 in it, it is a quartic. Same logic applies to all of these guys, okay? A quadratic is still a quadratic if it's like x squared plus 2 or x squared minus 9 or something like that, right? Like, it's still a quadratic even if it doesn't have a bx in it, okay? So this is like something that we're going to look at. Now, we're only going to go up to quartics in the A-level specification. I believe quintics are in further maths. Quartics are the highest for normal maths, okay? So we only need to look at up to here, okay? So I'm just writing quintics to show that they do go above. You know, these things can go on infinitely long, okay? And that's called a power series. Again, well, actually it is in A-level maths. I tell a lie. Binomial expansion second year. But guys, this stuff up here, this is what we're looking at. For A-level maths, you must be able to sketch any of these, okay? You must be able to sketch any of the things in this box, yeah? But that's what we're going to do. We're going to talk about, we know how to sketch constants. That's literally just like y equals 5, okay? It's a line going through 5 that's perfectly horizontal, that's it. We should know how to sketch y equals mx plus c, but we have not done videos on it. So if you don't know how to sketch a linear graph, don't worry. Don't feel like we're going ahead of like, oh my God, like, I don't know how to do this, but I am about to learn how to do all of these. Like, don't worry. There's a whole chapter on linear that we'll do. Quadratics we should be experts at. Cubics and quartics, that's literally what this chapter is for. The next videos we'll be talking about cubics and quartic, okay? So on this side of the board, I've sketched a sort of general looking cubic. If you want to know what one looks like, they look like this roughly. You can have others, you can have one that looks like, I don't know, maybe it looks like that, you know, whatever, X and Y, just sort of a sketch. They look like that. They look a lot like quadratics, but instead of going either, like obviously I'm just filling this board now, a quadratic might go like this, right? Quadratic goes either down and up or up and down. That is it. These higher order polynomials, and remember a polynomial is just something that looks like any of these higher order polynomials just look like quadratics, but they sort of have more curves in them. They just wavy, like there's one more sort of thing, like this, if maybe a quadratic would come up, down, and maybe this would be your quadratic, but the cubic comes up and then down and then back up again. But it will never come back down after that. It's done after that. It's just going to shoot up to infinity. It will not come back down again. If it was a quartic and it was 1 power of x higher, it might come back down. It might go up like this, and then it might come back down again. But again, it would never come back up after that. It's done. But thank you guys for watching this video. We're going to get right into it, and we're going to start actually learning about how we can figure out how to graph these bad boys.